So in this tutorial video, I'll show you how to map the expression of genes onto our single cell data, both at the level of single cells and at the level of clusters and subclusters, and I'll explain what that means. So for this tutorial, I've loaded the frontal cortex data set, and we're looking at the tSNE plot of the global clustering, so the cell classes here. And you can see all the clusters that correspond to astrocytes, neurons, oligodendrocytes, all the cell classes in the brain are shown here, and they're numbered. And this color-coded and numbered clustering will change the moment I look up a gene. So under the Query tab, I can go into Gene, and I'm going to look up GAD1, which is a marker of cortical interneurons. And when I do that, you can see now on top of the color-coded clusters, we have GAD1 expression shown by black dots, where the size and opacity, the alpha of those dots, reflects the fraction of UMIs in that cell that are GAD1 positive. Okay, so we can clearly see that cluster 1 and 2 here have very high levels of GAD1 expression, and indeed those are the interneuron clusters. So we can change, there are several options for how we display gene expression profiles in the tSNE plots, and you can access those through the Display tab. So for example, I've shown you transparency mode, where we're overlaying the GAD1 expression levels over the clusters. We can also switch it to hot-cool mode, and the hot-cool mode, only the clusters over a certain threshold for GAD1 expression are shown, and you can adjust that threshold here. Okay, so there's a variety of options for looking at the gene expression mapping in tSNE space. Now, if I go back to the Query tab and say I'm interested in the second gene, we'll use a marker of vGlut1 expression, the protein, which is SLC17A7. And if I type this in now, a second plot is generated showing the expression of SLC17A7 and which clusters are positive. And so in this kind of single cell mode, we can see clusters 1 and 2 correspond to interneurons, and 3, 5, and 6 to excitatory populations that are SLC17A7 positive. Now, say I'm interested in a third gene, LYPD1. We can now look at that, and we can see that LYPD1 is highly expressed in cluster 4, which is also SLC17A7 positive. We can also start to see gradients of expression in some of the other clusters that are really very strongly positive for certain neuron markers. Okay? So this is how we can look at gene expression patterns at the single cell level in tSNE space. But we can get more quantitative by using the levels for cluster button. Now, what I'm going to do is, before I get there, I'm just going to erase these other genes to get back to a single gene, GAD1. And now if I click on levels for cluster, we can see these plots where we have GAD1 expression at the level for each global cluster in the data set. Okay? So we have, and they're ordered by the level of GAD1 expression. So you can see the CG interneurons on average per cell have around, when we scale those cells to 100,000 UMIs per cell, around, on average, 200 of those UMIs are GAD1 positive, and around 110 are GAD1 positive in the MGE, the somatostatin part of abdomen interneurons. And these error bars reflect 95% confidence intervals of binomial sampling error around those UMI measurements. Okay? So this is at the level of the global cluster. Now, if we want to look at all the subclusters in the data set, we can now click over to the subclusters tab. And now, instead of looking at cell classes, we're looking at all the individual subclusters in frontal cortex. And now you can see we only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 displayed. But if we go to the Display tab, we can change the number to, say, for example, 200. So we can look at a massive number of clusters at a time, right? And so this is all the expression for GAD1, and you can see the highest levels are in the subcluster 1.2, which is mapped by complexin and realin, and you know, we can look at the expression of GAD1 in this particular way, and we can see very little expression in some of the non-neuronal cells here, for example, the astrocyte subclusters and the neuron subclusters here. Now again, through the property of limitation, we can go back to the query and say now we're only interested in the subclusters of the interneurons. So first we can select neurons. So now only neurons, the subcluster neurons, will be shown. And then furthermore, we can limit our analysis to particular subclusters. So the CGE cluster was very high for GAD1. Let's look at the MGE cluster, right? And now things will be reconfigured, and I'm just going to adjust the display here back down to 20. And we can see now we're looking at GAD1 levels just within the interneuron population, which corresponds to cluster 2. Okay. So that's a single gene, but what if we wanted to map multiple genes? Okay, so for example, GAD1 here, we can put in SLC17A7, our VGLUT1 gene, and we can see now that the interneurons, as expected, that are GAD1 positive, have virtually no levels, virtually no expression of SLC17A7. But of course now we're just looking at the MGE somatostatin parvalbumin interneuron cluster 2. Now say we want to look at all neurons, we can just erase that limitation, and now we can look, and we'll go back to display 50, and now we can look at the expression of both genes ordered in the same way. And as expected, we see the clusters, subclusters that are high for GAD1 are low for SLC17A7, and we can find maybe some instances where we have co-expression of both. Okay? So again, this is at the level of the subclusters. If we wanted to turn it to the level of the global clusters, now again, we can click on the global clusters tab, and we'll adjust this back down to 10, because there are not that many global clusters, right? And we can see the expression levels again of GAD1 and SLC17A7. But let's now open it up, and we looked at the LYPD gene before, so I'm going to put in a third gene now, and you'll notice that the format of the plot is going to change. So instead of being these dot plots with error bars, now we get this table where expression level is represented by the opacity of the dot. And this is a really helpful format because you can put in as many genes as you want here and then sort the table in a variety of ways using these arrows. So if you're looking for clusters or subclusters that express multiple genes, this is a very helpful format for doing that. Okay, so I hope this has given you a sense of how you can search the entire data set for genes of interest. So for example, if you're creating a knockout mouse and you want to know which cell types you think are going to be affected because they express that gene, you could go into the query section and you could select all of the tissues, put in your gene of interest, and then go to subclusters, and you will see the expression of that gene in the 500 plus subclusters that we define in our atlas. Okay, so hopefully that is helpful.